to days and 3 days because there are there is no more slack for this one. Although you can see from B, E, and F, we have at least one slack time for it. And to find the project completion time, that would be the maximum of the earliest finish times at the finished notes, which is 11 weeks. So you can see from here. So that is for the question 1A and B. And then in C, we are asked to develop a numerical model to identify the critical part for our project. And this one, we have a discussion, and then we decided to take our introduction to logistic and supply chain management project at year one to represent this. And our group was we worked with Mr. Hui to for the laser cutting machine application in the manufacturing products. So with it, so first we list down all the activities that we've done during that project. So we have like first we attend the orientation day with the IM school, and then we meet the advisor, and then we have some group meeting, and we discussing that what we do at that time. And then we came to the design, the logo on the laser cap printing, and so on and so forth. Yes, we have to purchase and buy the mica, the material. Yes. And at the same time, we need to prepare for the reports and also the script for the presentation at the defense dates. um, yeah, and then that's it. So, and we just estimate the hours needed for these activities. That's from here. So actually, it will be carried by days, but we transform all into the hours, so you can see it easily. Because some activities just lasted for 1 or 2 hours only. Yeah. And we also add some dummy activity to we can present it here. So the dummy activities means that in order to complete the R, you have to wait for the P and Q finish. Not only just from O, that is the dummy activity. And then for the numerical formulation, we follow by your instructions in the slides, and then we can come up with this one. So
Wonderful.
The objective function here will be so minimize the TN. And we can see the TNs here. The time for all the numbers of events in the network. We have to minimize it. That is our objective. We have some constraints. And for the gain chart in our projects, we using the Excel file to come up with this one. Let me share with you the Excel file.
Keep sharing. Oh my God.
Yeah.
Keep sharing. Yes, keep sharing your file. A wonderful file, especially
so this
diagram.
Activity
this is on arrow. Yeah. And mathematical model. Did you study OR1?
Yes, we study OR1 and OR2. So we deal with models on the time.
Yeah. You know, OR1 is so important.
Yes, that is like the first. Okay, so for the gain chart, we conducted in the Excel file.
I know.
We know some tools, but I think the Excel file will be easier for us to.
It works.
Yeah, it works well and easily to follow.
Yeah.
You can use directly right away in the chart design. Yes. So we just copy the table of activity, and we can estimate the start and the end day with the duration in days. We transform the hours into days. Yeah. So
that's why they call it Excel. Excellent. Okay, go to your mathematical model.
Yeah, so here's the first we identify the index. So in the index, we have
Yes.
the end, and will be from 1 to 19. It means the set of the nodes or the events in our table.
Well, I'm sorry, Ming. Are you sharing your screen because I can't see anything.
Oh, wait.
Yeah.
So sorry.
Been sharing the screens.
Can
Please.
you see it now?
You can pink. Yes.
Everyone, can you see it now?
Yeah. Okay. Very good.
Okay.
V. Thank you, V.
Yes.
Thank you very much.
So,
You just explain a little bit.
so like for
More.
most of the numerical models, so we first have to identify the index, and then the parameter. So the parameter here should be the length of the activity. And yes, we have to identify the decision variable. So this will be changed. And the two main parts will be the objective function and also the constraints for our actual. Yes.
Yeah. You see, huh? Oh, let's see. You see, first the objective functions. Okay. They add the constraint, and before that they have index.
Yes.
Parameter and variable.
Yeah.
Especially here is decision variable. Okay, it could tell us when to decide. Okay, to start. Okay, to finish. Okay, that's why they call the decision variable. Many kind of variable. Okay, but in this case, decision variable. Very good. Hello class, do you have any questions? And what did you solve? How can you solve such mathematical model?
So in order to solve this one, we have numerous ways that we have learned the lingo or the simplex.
Yes.
Yeah, we can transform this one into the code, and then we can run the solver, or we can run on the Excel. I'm not sure we can run on the Excel or not, but I think lingo or simplex will work.
Did I show you before? You solver.
Yes, already. Yeah.
Yeah. Okay. Very good. Okay. You present activity in arrow. Very good for coding. Okay. So keep going on, sharing your work. I have some questions.
Okay. Yeah.
Okay. So any questions? Because you are IE people, you figure out the diagram very fast. Okay. And in this case, very nice because many ways to present, and you can rearrange, and you can have a network look very nice at it. Okay. From this logic to build the formula. Okay, for the constraint. Okay, and they explain in detail of constraint, function, etc. Now, Ramcha. See? Ramcha. Hello. Min, I ask also you.
Yes.
You see Ramcha? What is triangle in your Ramcha? Why? And how to improve it? Hello.
Yes. Can
you see the Ramcha? Hello, class. Do you see Ramcha clearly? Student, take a look in the Ramcha. Tom, good. Do you have any comment in Ramcha which Min is showing? Take 1 minute for you to see Ramcha. Some parallel.
Yes, because some of things we work at the same time.
Yes, it's good. It's good. But you see, how can you can maximize it, huh? I can maximize in the mean
Yes.
the first day, maybe
Yeah.
several hours, right?
Yes.
The
It takes
seconds.
like 1 or 2 hours. Something.
Yeah.
Yes.
So how can it not continuously? You can see design logo for laser CAD printing very long, and right after that, okay,
Yes.
is learning AutoCAD right after that, okay. But how can the first and the second not right before? How can? Why?
So actually, the first and the second activity.
Yes.
So we have to
Not connect to each other. Why?
because they just 4 hours, and in the x-axis we represent it by days, so it's kind of really far from each other because it takes up a few hours in that day. Yes.
We know.
So
We
that's
know
why.
it's only few hours. We know
Yeah.
that. But how can? So hello class. This is very important. Okay. So orientation day with our school is one project. It's stand alone. It's stand alone. Right? You remember after one activity must be some another activity. Hello, mean the rule.
Yes.
The rule. Remember, the
Yes.
first activity must have the follower. Okay? Just present the grand chat. Hello. Just grand chat first. So what does it mean? Hello, Tham. Do you have any comment, questions?
Not yet, sir.
Yes. Hello. Min, do me a favor.
Yes.
Why we have to stop here, you know? Your Ranchak is very good, but need to correct.
Yeah.
Right after the first activity, you need to put some activity. You say, wait.
Yes, I see.
Okay?
Yes, so there is an idle time here, right?
Yeah.
I will
You need
figure
to
out how
wait.
to correct it. Yes.
Okay? The first 3 activity, you need to correct it.
Yes.
We know number of day, but hour, but it must be correct. And as you see, it's connect to each other. You know the rule after the first activity must be followed by some activity right away. Not, I know, orientation day take several hours only. So after that, you need to, for example, you define working day is 8 hours. Okay, 8 hours.
Yes.
And orientation day with our school maybe 4 hours. So you need to add more 4 hours. For example, you wait for something. Okay?
Yes.
So it continuously to fulfill one day. Same. The activity number, the second activity, I mean, brief planning. Okay, some hour. And after that, you add. So it continuously. 1, 2, 3, and 4. Activity 1, 2, 3, and 4. Okay?
Yes, we got it. Yeah.
Got it. And also same with the next one is consulting advisor about the physics sample.
The first time.
Okay? Somehow, how can it stand alone? It stand alone, it means it is one project. Okay. Hello, Min.
Yes,
I think Min already recognize it. Okay, realize.
yes.
Hello, class. Okay, never have any activity stand alone. Alone, not parallel with another. For example, you can say activity 6 and 7. They can stand alone, 6 and 7, okay? But it parallel, right? 6 and 7. It parallel to activity 4, right? So it's
Yes.
acceptable, right?
Yes, right.
Okay, that is. Okay, so be careful because you study my project management course. You present the Gantt chart, and you know, in the project, they review Gantt chart very often, every meeting. And when you show such Gantt chart with some activities stand alone, okay, it's not correct. Okay, so that's why we have to stop here to review the Gantt charts. Very careful. Okay.
Yeah.
Thank you, Min.
Yes.
Yeah. Okay. With that, I think today, any questions from another?
So one friend asked that can a number of days duration be a rational number? So I would say that actually we start with the hours and then we transform it into the day, so it will become the rational numbers. We will not define at first that is the rational numbers, but we transform it into days.
Yeah.
Yeah.
You know that we use Excel. Okay. If you use project, also from Microsoft, huh? But if you use project software, okay, they will ask you, okay, because they have dedicated start to start. It means parallel, okay, parallel. Stop to start. It means serial. It's serial, okay. So if you not connect it, you didn't connect it directly. If you alert a mistake, okay, okay. So that's right. Very practical. Okay. Thank you, Quyên. Very practical. Okay. So with that, we go for group 5 today. Okay. Okay. Yeah. Perfect. Okay. We learn every day. Okay. Huỳnh Thúy Vi, are you ready?
Yes, we are ready.
Yes, and share your screen, introduce your team member, and the simple rule. Say your name, turn on your camera when presenting. Okay, if you present again, you also need to introduce yourself. Okay, please do your best. Hello class, many techniques today. Previous week we had practical parts, and now we also have such kind of own location. The reasons is that you know the resource is limited. Remember, every resource is limited except your brains. Okay, your capability. Okay, resource is limited. So own located. Let me see. Let me see. Resource. All resource are limited. Okay. Natural resource, etc. Limited. So you own located. What do you mean own location? Okay. In the priority. Hello. Okay, I didn't hear anything. Okay, now it's good. Own located. First priority. Okay. For example, in your student life, you also need to allocate your resource to maximize what is the main objective, and maybe to smooth something. Okay, so it's very important in terms of cost, in terms of service, anything depend on your objective, and objective is based on your viewpoint, your standpoint. Okay, that is with that. G5, please start with. Hello, V.
Yes.
You just share your screen. And who present control, take the control, you the laser pointer. Okay. Hello, V. Who will you be presented first?
Yes, I'll be the first presenter.
Yeah, just share the screen.
Please wait a minute.
Okay. So you see people talking about planning. Okay. And now we have a task of planning. Okay.
Sorry. Can you turn off your sharing so we can share our screen?
You can. You also can. Okay. Can you just share? Okay. Yeah. Thank you.
Yes, everything is okay now. So, good day, everyone. How are you today? I hope you're all doing well, as today we are going to discover another interesting part about the project management. I'm Thủy from Group 5. It's our honor today for each and every member of my group to present Chapter 5, Resource Allocations. For this lecture, we consider the allocation of the physical resource. The subject relates directly to the projects of scheduling because altering project can alter the need for resource, and just as important, alter the timing of resource needs. This chapter addressed the situation that involved resource problem. We discussed the trade-off involved, the relationships between resource loading and leveling, and some of the approach involved to solve the allocation problems, including the critical path method or CPM, constraint resource diagramming and scheduling, the concrete critical change, and another approach to solve the problem of scheduling and under conditions of resource scarcity. First, we will start with Minh Uyên for the last week review lesson.
Thank you.
So hello everyone, my name is Uyên, and before the content of this chapter, I have a small review section for you guys. Next slide, please. First, about the project time management plan, we have 5 steps: define activities, sequence the activities, estimate activity resources, and then estimate activity durations, and finally develop the schedule. Next slide, please. About the task sequence activities, we have 2 ways to set up a network graph of activities, AON or AOA. So first, about the AON graph, it is the activity on node graph. In the AON graph, activities are represented on nodes. Here you can see each activity A, B, or C is represented by a node. The arrows are used to denote the precedence relations among activities. Next slide, please. And in the AOA graph, which is the activity on arrow graph, activities are represented on arrow. Here you can see each activity A, B, or C is represented by an arrow. The precedence relations among activities are introduced by defining events. The events are the event number 1, number 2, number 3, and number 4, and so on. Next slide, please. And after finishing sequencing, we need to estimate the activity duration. An activity duration can be calculated using this expected time formula, which is the mean formula you can see on the screen. So here, A is optimistic time, M is the most likely time, and B is the pessimistic time. The variance of an activity can then be calculated using B minus A divided by 6 squared. And the variance of the project is the sum of variances of own activity on the critical path. For example, the critical path here is ACFIK. So the variance of the whole project will be the sum of the variances of ACFIK. Next slide. And to determine the probability that the project is completed within a specific time, we can use the Z-score formula here. So mu here is the project mean time, sigma is the project standard deviation, x is the proposed project time, and z is the number of standard deviation. The proposed project time is from the mean. And also we can build linear programming models for our project. The objective is to minimize the time at the last event. Ti is the starting time of the event I. The constraint can be set up like this. For example, the duration for activity A is 5. So T2 minus T1 is larger than or equal than 5. And we can formulate all the constraints just like this one. A note here is T1 must be 0. And lastly, I will talk about the Gantt chart. A Gantt chart is a horizontal bar chart that visually represents a project plan over time. A modern Gantt chart also shows the status and who is responsible for each task in the project. The key elements of the Gantt chart are first the task list, timeline, deadline, the bars, the milestone, the dependency, the progress, and resource assigned. And to know how to draw a Gantt chart, you can refer to the last chapter. And that's the end of the review section. Please now welcome Vinh for the first part of the lesson.
So my name is Vinh, and today I will present about the definition critical path method and the formula critical path method. So unfortunately, the camera is some problem, and I don't turn on. Sorry, teacher and many students in the class. Okay. What is the critical path method? Critical path method includes a way of relating the project schedule to the level of physical resources allocated to the project. CPM stands for a critical path method, and I use the CPM is sorting in this presentation. And CPM allows the project manager to trade time for cost or vice versa. In CPM, two activity times and two costs are specified if appropriate for its activity. So in the next slide, I will show you more understanding about critical path method or CPM. Okay. The first time divide cost combination is called normal cost, and the second set is referred to as rush cost. Normal time, so understand is a normal in the same sense as the M time estimate of the 3 time used in PLRT. PLRT, the most of students study it in previous week, and I don't explain me in this chapter. So the next is rush time result from an attempt to edit the activity by the application of additional resources. Or next slide, I will show example about critical path method. Example is expediting house building process by tracing project. The first is defining the step 1, step 2, step 3, and step 4. The step 1 is define element weather. The next step is delay in pouring if element weather. So you delay in pouring a house foundation, and next step is delay all the steps. Unfortunately, and so they have many problems. The proofer are only available during the day schedule for your project. I can explain it like a construction contractor might choose to employ a different type of project tracing. Element weather cause a delay in pouring house foundation, which subsequently delay each step. Unfortunately, the roofer are only available during the day schedule for your project, so the contractor has a choice. They can either pay extra worker to frame the house more quickly, so the roofer can proceed and they were originally scheduled, or wait until they have another opening to put a roof on the house. Waiting until the roofer have another opening might seem like a choice that could preserve the budget, but it would likely lead to more delays in sending elements like electricity or flooring, which can be started without a roof. Additionally, additional delays will inevitably impact other scheduled projects that can start because manpower is tied up in this complete house because the scope of the project cannot change in order to reach completion. Rushing activity will be necessary here as well. So the next slide is the conclusion. For this example, we can, the next slide is the construction contractor has choose choice. The one is wait until roofer have another opening to put a roof on the house. So we can trade off preserve budget or more delay in sending element electricity. The second choice is pay extra worker to frame the house more quickly, so the roofers can proceed as they were originally scheduled. This helps save time, increase cost, trade-off between time and cost, but more appropriate in this case. So I think in this case, according to me, I choose pay extra worker to frame the house more quickly. The next slide is so explain me some term of critical path method. The first term is careful landing. Careful landing is critical when attempting to expedite a project. Expediting tends to create problems, and the solution to one problem often creates several more problems that require solutions. Some organizations have more than one level of tracing. So, what is the project tracing? The next slide will show you the project tracing. The project tracing is a method for shortening the project duration by reducing the time of one or more of the critical project activities to less than its normal activity times. What is the objective project tracing? The project objective of tracing is to reduce project duration while minimizing the cost of tracing, because in trade-off the time and cost. So we can minimize the tracing also mathematical model or constraint. Two simple principles: focus on the critical path when trying to shorten the duration of a project, The second is when shortening a project duration, select the less expensive way to do it. So I show you the formulation of the pricing a project. The first step is compute the rush cost per time period. If rush costs are linear is concentrate in a linear over time. Rush cost period equal cost minus normal cost divide normal time minus rush time. The next step is using current activity times to find the critical path and identify the critical activities. Second, three step is the third step is select the activity to rush. If there is only one critical path, select the activity on this critical path that can still be rushed. Pay the smallest rush cost per period. The fourth step is if there is more than one critical path, select one activity from each critical path such that each selected activity can still be rushed. The total rush cost of unselected activities is the smallest. Note, the same activity may be common to more than one critical path, and 5, update on activity times. If the desired due date has been reached, stop. If not, return to step 2 and step 3, step 4, and step 5. So that is the end of the presentation. The next session is Ngọc, and Ngọc will introduce about the exercise rushing a project, for example. What, Ngọc?
Hello everyone. So my name is Ngọc and I am responsible to present the section crossing a project. So here we can see all the information we need in order to cross a project. Assuming that the project manager wants us to finish the project within 110 days, so we need to determine the minimum cost possible for the project. Next slide, please. So this is the graph given. Next slide, please. So the first step is to calculate the slope cost by using the formula given. We can calculate we can compute the normal cost by taking the sum of normal cost of all activities, and we can calculate the normal duration, which is 140 days. Next slide, please. We can easily see that the critical path is B, C, D, E. There is one critical path, so we need to cross this path first. Next slide. We can see that the smallest slope along the critical path here is activity D. So we cut it from 30 to 20 days. So the new critical path remains the same, which is B, C, D, and E. The more normal duration is 130 days because we cut the maximum 10 days of activity days, and the new cost is calculated by taking the normal cost plus the slope of activity D multiplied with the number of days cut. Next slide, please. However, we cannot, although the critical path still B, C, D, and E, however, we cannot cross activity D anymore, so we need to cross the next smallest slope, which is activity E. Similarly, we cut it to 10 days with an additional cost of 100. And so with additional cost of 100 and
Ngọc, can you please stop a bit because our teacher has something to say.
Okay.
Teacher, do you have anything to say? Because I saw you raise your hand.
Yes. Okay, thank you, Ian. Sorry, Ngọc. First, please slow down a little bit. I hear some requests about slowing down.
Okay.
First, the second, you see underlies what is the critical paths, okay? And you review critical paths. At previous week, you see that at least one critical path, and critical path is moving when we crash another activity in another path. Okay, that is so important. Okay, just thank you.
So please move to the previous slide, the previous one. Do you mean that I need to explain again how I can get the critical path, teacher?
Yes, almost like that. The first, identify the critical paths. Okay, how to estimate the duration. Okay, the second is to ranks do activity with the least cost for crashing. You can see we highlight in yellow, greens. Okay, step by step like that. Okay, thank you.
Okay, thank you. So the first step, we need to calculate the crash cost here, and we get the value of cost slope, which is activity A. We get the cost slope of $100 per day, and similarly for the remaining, which one had the smallest cost slope, we'll get the ranking first. We'll have the first ranking, and we need to crash this path first, crash this activity first. And next slide, please. And in this figure, we can I explain the critical path later, since I had not prepared. So may I explain it?
Okay. No problem, Ngọc. Take it easy. Now,
Okay.
by the way, you know B, C, D, E is critical path, right?
Yes.
Because it's the longest. Okay. Right?
Okay.
Yeah, very
I
simple
also
like that.
think.
Okay.
Okay. Thank you. And since the normal cost, we just the previous slide, please. In order to calculate the normal cost, we just take the sum of all the activity here. So for example, activity A is 12,000, activity B is 1,800. We just take the sum of this column. We can get the total normal cost here is $48,300. And the normal duration in the longest, the critical path E, B, C, D, and E, we just check the normal duration of each activity, and we can get the normal duration here is 20 plus 40 plus 30 plus 50, 100 equal 140 days. Okay. Next slide, please. So as I mentioned earlier, the critical path E, B, C, D, and E, and activity D has the smallest slope, which has the first ranking. So I will crash these activities first, and these activities can be reduced maximum 10 days. So I cut it 10 days from 30 to 20 days, and the new durations is still the new critical path, which had the longest duration is still B, C, D, and E, and it equal 130 days. And the new cost, I just take the normal cost plus the cost slope multiplied with the number of day cut. Here we can see that the normal cost is 48,300 plus the cost slope is 60 and the number of day cut is 10 days. So we just have the formula here and we can get the new cost. Okay, thank you. Next slide, please. In this, I mentioned the critical path is still B, C, D, and E. So although the critical path remains the same, however, activity D cannot be crashed anymore. So we will choose the smallest cost slope among the remaining activities. So I will choose activity E, which had the smallest cost slope until now, and I will crash it. I will cut the number of days to 10 days with an additional cost of 1,200. And we can easily calculate the new cost which equal 48,900 plus the additional cost. And the new critical path, right now there are 3 critical paths which have the same duration of 120 days. The first critical path is A, the second one is B, C, D, E, and the third one is B, F, B, C, I cannot see here, B, F, and E. So, since there are 3 critical paths, I will choose the one activity from each path to crash it. So we can see that there are 2 options here. The first option is to crash activity A along with activity B, which add an additional cost of $300 per day. And the second option is we will crash activity A along with activity C and F, which add an additional cost of 1,000 per day. So we can easily choose the first one as it had less additional cost. Next slide, please. So the new critical path is still the same, which had 115 days. The new cost, we will take the cost of previous stage plus the additional cost multiplied with the number of day cut is 5 days, and we will get the new cost here. So, however, we have not reached the goal of 110 days. So we need to crash the project again. There are still 3 critical paths, and I will choose one activity from each critical path. Here there is 1 option left, so I will reduce the duration of activity A by 5 days, activity C by 5 days, and activity F by 5 days. So we can get the goal of the normal duration. Right now is the crash duration of 110 days with the total project cost of $56,600. So do you have any questions before I move to the next example? Yeah.
Hello, class. Do you have any questions?
No, sir. It's much better now.
Much better now. Thank you, Thắm. Now the people Nghi, Hiếu, you see critical paths in moving because we crash some non-critical activity. So with that, we should summarize the process. Okay. I think Ngọc already present in the sample. Very good. Thank you. So go ahead.
Thank you. So I will move on to the next example. So in this example, the first step, I also calculate the slope. Next slide, please. Next one. Move to the next slide. Here's okay. At the first step, I will also calculate the slope and calculate the max grass time here. Can you move to the previous slide? Okay, the previous one. The previous one, please. The previous one. Okay, yes, here. So, assuming that the project manager wants us to finish the project within 20 days, so I will find the minimum possible cost in order to reach the goal of 20 days. Next slide, please. Okay. We can easily find that the critical path, which is the longest, which have the longest duration, is 1, 2, 3, 6, and 7, with the total normal duration of 23 days. As we sum on the normal duration 3 plus 6 plus 8 plus 6, we will get the normal duration of 23 days. And the normal the project cost is we can sum on the normal cost of all the activities. Okay, next slide, please. Okay, I also presented it before. We calculate the slope and calculate the max crash time in order to determine which activity we will crash first. Next slide, please. So, okay, next slide. So we can easily see that activity 1, 2 had the smallest slope. So I reduce it to 2 days. And we can see that the critical path still remain the same, which is 1, 2, 3, 6, and 7. So I will crash it again with activity 3, 6. I reduce the number of days to 6 days, and we can get the crash path, the crash duration of crash path, which is 20 days, and the crash total cost, we take the normal duration, normal cost plus the additional cost, and we can get the crash cost, which is $840. So in this example, since it's similar to the first one, so we do not explain in detail. So do you have any questions? I will answer. Okay, if not, I will invite he for the next section.
So in the previous part, we have learned how to rush a project to meet the timeline. Besides, we still have one more method that's called fast tracking. Usually, we can say that the designs will be complete first, then before the construction starts. However, fast tracking suggests that we can overlap these two activities to shorten the project duration. So let's consider the reverse example, building a house. So in rushing session, we say that the manager will hire more workers and roofers to expedite the project. However, in the fast tracking, we will keep the same numbers of workers and roofers, but the succeeding activities like electricity and flooring
can start when the roofers are halfway done. They don't need to wait until the roofers finish all the jobs. But this method also has some drawbacks. Firstly, it will increase the change orders, but because two activities will work at the same time, then we have to reschedule the succeeding activities. Subsequently, it leads to the loss of time and increase the risk. Secondly, loss of productivity, as we have to do two or more than two tasks at once, which means we have to do the multitasking at once, so the productivity may reduce. And last but not least, the fast tracking can only apply for the activities that can be overlapped. So manager should be careful when he or she choose this method to expedite a project. Next, I will move to the resource allocation problem. So we can easily realize that when talking about scheduling procedures, people hardly address the resource utilizations and availability, but they tend to focus more on time. We can't deny that time is a critical resource because it can neither be inventory or renewed. However, schedules should be evaluated in both terms of timing and scarce resources. So a fundamental measure of the project manager's success is the skill with which the trade-off among performance, times, and costs are managed. So in the trade-off relationship between time use and resource use, there are two extreme points: time limited and resource limited. Time limited means that there is no resource constraint, but the project rather use as few resources as possible. However, this project must finish by a certain time. Opposingly, resource limited means that there's no time constraint. It just needs to be finished as soon as possible, but there will be a specific level of resource that we cannot exceed. And occasionally, time and cost of one project will be limited. However, in this case, specifications will be flexible. But if all the three variables are fixed, then we call this system is overdetermined. And if the system is overdetermined, the manager has lost all of the flexibility to perform the trade-off between time, cost, and specifications, which is really important to the success of the project. Here we have one example of the overdetermined project. In this project is led by a less experienced manager. He plans the steel bolts to be delivered during the 5th month of execution. However, the foundation work starting in month 9, and foundations also require the curing time. So it takes quite a while before the posts could be planted. Financially, it means that we have an asset in stores, but we cannot capitalize on it because it wouldn't be in service. And moreover, this project is planned to start in the heavy rain season, which was just impractical. And we can say that because the manager has a fixed schedules for this project, but he didn't consider the real conditions that leads to the incurred costs and schedule delays. But in some cases, there's one or more tasks in a project that needs a fixed amount of time and known quantities of resources. We call that is system constraint tasks. For example, in heat treating, the material must cook for a specific time to achieve the desired effect. More or less cooking will not help. Also, the interest in these cases will just to make sure that the required resources are available when needed, because no trade-off are possible. And this is the end of my part. The next part will be resource loading, and when we present to you.
Okay, hello, I'm Win. And now I'm going to explain to you guys concept regarding resource loading and resource leveling. These two are important concerns when we analyze the project resource utilization and its impact on project scheduling. So now let's start with resource loading. As you can see in the slide, resource loading describes the amounts of individual resources that an existing schedule requires during specific time periods. In such resource loading, the loads, or we can simply say requirements, of each resource type are listed as a function of time period. In other words, basically, resource loading means allocating resources to the activities at the right time. The question is, why do we have to consider about resource loading? Well, it gives estimation of the cost and quantity of resources. With the help of resource loading, project manager can calculate previous slides, please. With the help of resource loading, project manager can calculate the employee working hours and do the allocation of various tasks. And therefore, he can predict if he needs to add any employees to the project team for the completion of the project or not. For you guys to understand more, let me introduce an example. Like you have a company that has 2 ongoing software projects and a total of 25 technical employees. In order to carry out both projects, the employees need to be allocated logically at every required stage based upon the requirement and priority of either of the project. One of the ways to solve this problem is using resource loading. From all I have said, we can see that resource loading is an excellent guide for early raw project planning, a first step in attempting to reduce excessive demand on certain resources. Next slide, please. Well, in order to derive a resource loading document without difficulties, we need an action plan. So what is an action plan? Project action plan is the source of information on activity precedences, durations, and resource requirement. We can see that this is a primary input for both the project schedule and budget. Then, consider as a primary input. This is because the action plan links the schedule directly to specific demands for resource. So as I have already talked about the theory-based project action, like what it is, what it has, so you might curious how this look like. This is actually what the project action plan look like. We have here a project action plan regarding IU software, very familiar. Well, in this plan, you can see the name of activities that need resource is listed, followed by the list of each of the human resource used in the project. As we can also see the responsibility columns like secretary, program manager, we also have the total estimated hour for work for each resource, like the secretary needs 6 weeks for printing forms. The activity precedences, like the program manager needs to wait for the form to be done before contact with the organization, and other resource needed. I believe that we have known why we need resource scheduling and what we need to carry out such work. But then how can we do it? Next slide, please. Well, the PERT CPM, Project Evaluation and Review Technique Critical Path Method, what we have just learned in previous slide, can be modified to generate time-phase resource requirement. But then there are some things that the project manager must also be aware of. First, he must be aware of the ups and flow of usage, which means the up and down movement of usage for each input resource throughout the life of the project. Second, he must ensure that the required resources in the required amount are available when and where they are needed. I believe that's all the basic things we need to know regarding resource loading. So let's come to resource leveling in next slide. Firstly, resource leveling aims to minimize the period-by-period variations in resource loading by shifting tasks within their select allowance. It deals with time-frame project resources, which includes the project budget and manpower. In other words, resource leveling balances the need of the project with respect to the available resources at every stage, with time and available resources at the two main components. Projects with higher priorities will be completed first with the available resources. In technical words, we can say that the tasks on the critical path are completed first with the available resource. Let's take the same example where there are two software projects, like I have just said. Resources are allocated to the project which needs to be completed first or which is on the critical path. From the above explanation, we can see that the purpose of resource leveling is to create a smoother distribution of resource usage. Next slide, please. So we're here again. Why do we have to perform such phase? Let me introduce you the advantage of resource leveling. Within the managerial implications, resource leveling leads to less hands-on management, which means a situation where a manager involved in day-to-day activities and decisions of team. How? Well, we can see that such situation can be limited if the use of the given resource is nearly constant over its periods of use. The project manager can arrange to have the resource available when needed, can have the supplier furnish constant amount, and can arrange for a backup supplier if advisable. Moreover, the project manager can do this with little error. Also, resource leveling makes us able to use a just-in-time inventory policies without much worry about the quantity delivered will be wrong. Within cost indication, when resources are level, the associated costs tend to be level. Just like resource leveling, the project managers also need to be aware of several things. In this phase, the two things are the cash flow associated with the project, the means of shifting them in ways that are useful for the parent firm. In brief, resource leveling is the procedure that can be used for almost all projects, whether or not resources are constrained. Next slide, please. To close the concept of project leveling, let me help you to distinguish between resource leveling and resource smoothing. For short, resource leveling is used where limits on the ability of resource are paramount. It simply answers the question, with the resource available, when will the work be finished? Therefore, you can see in the first picture, the resource leveling, the works are not finished within the original first finished date. How about resource smoothing? It is used when the time constraint takes priority. The objective is to complete the work by the required date while avoiding peaks and trough of resource demand. So you can see here there is no delay. All the works are finished within original finish date. That's all of my part. Yeah, we will continue our lessons today.
So thank you, and now I'm going to continue with the constraint resource scheduling. So this type of resource scheduling is a solution to project managers' failure to include resource availability in risk identification activities. There are two fundamental approaches to constraint resource allocation problems, namely heuristic methods and optimization models. While heuristic approaches employ the rules of thumb and seek for better solutions, the optimization approaches seek the best solution. However, it is still far more limited in the ability to handle complex situations and large problems. About the heuristic methods, heuristic approaches to constraint resource scheduling problems are in wide general use for a number of reasons. First, they are the only feasible methods of attacking the large, nonlinear, complex problems. Second, while the schedules that heuristics generate may not be optimal, they are certainly good enough for most purposes. Most heuristic solution methods start with the PERT or CPM schedule and analyze resource usage period by period, resource by resource. In period when available supply of a resource is exceeded, the heuristic examines the task and allocates the scarce resource to them sequentially according to some priority rules. So among these priority rules, technological necessities always take precedence. Some of the common priority rules include as soon as possible, as late as possible, shortest task first, most resources first, minimum slack first, most critical followers, most successors, and arbitrary. Among these, minimum slack first rule was found to be best or near best quite often and rarely caused poor performance. Most priority rules are simple adaptation of the heuristic used for the traditional chop-shop scheduling problem of production or operations management. Most heuristic use a combination of rules, a primary rule and a secondary rule to break ties. As the scheduling heuristic operates, one of two events will result. The first one, the result runs out of activities before it runs out of resource. In this case, the excess resources are left idle and assigned elsewhere in the organization as needed during the current period or applied to future tasks required. Uh, in the second case, when the routine runs out of resources before all activities have been scheduled, then activities requiring those resources are slow or delayed until the next period when resources can be reallocated. About optimizing methods is the methods to find an optimal solution to the constrained resource scheduling problem and often fall into two categories, the mathematical programming and enumeration. Mathematical programming can be thought of as linear programming for the most part. Linear programming is usually not feasible for reasonably large projects where there may be a dozen resources and thousands of activities. In the late 1960s and early 1970s, limited enumeration techniques were applied to the constrained resource problem. Another optimizing method are tree search and branch and bound methods, which were devised to handle up to 5 resources and 200 activities. Then how about multi-project? The most common approach to scheduling and allocating resources to multiple projects is to treat the several projects as if they were each element of a single large project. Another way of attacking the problem is to consider all projects as completely independent. To describe such a system properly, standards are needed by which to measure scheduling effectiveness. Three important parameters affected by project scheduling are schedule slippage, resource utilization, and in-process inventory. The organization or the project manager must select the criterion most appropriate for each situation. The first parameter, schedule slippage, often considered the most important of the criteria, is the time pass of a project's due date or delivery date when the project is completed. A second measure of effectiveness, resource utilization, is of particular concern to industrial firms because of the high cost of making resources available. The third standard of effectiveness, the amount of in-process inventory, concerns the amount of work waiting to be processed because there's a shortage of some resource. A note when dealing with multi-project is that all criteria cannot be optimized at the same time. As usual, the project manager will have to make trade-offs among the criteria. A firm must decide which criterion to evaluate its various scheduling and resource allocation options. An approach to the multi-project scheduling and resource allocation is mathematical programming. Mathematical programming can be used to obtain solutions to certain types of multi-project scheduling problems. These procedures determine when an activity should be scheduled given resource constraint. Mathematical programming, however, is rarely used in project management to handle the multi-project problem. Mostly heuristics are used. The three most common objectives of mathematical programming are minimum total throughput time, minimum total completion time, and minimum total lateness or lateness penalty for projects. These objectives are most appropriate for chop-shop type solutions to resource constraints. The second approaches to multi-project scheduling problems is the heuristic techniques. There are scores of different heuristic-based procedures in existence. They represent rather simple extension of well-known approaches to chop-shop scheduling, including resource scheduling method, minimum late finish time, greatest resource demand, greatest resource utilization, and most possible chops. Now that's all about multi-project. Thúy Vy will continue with our last part, critical chain.
Yes, thanks, Zhao Ying. And it's my final part for this lecture about the critical change. So the critical change project management, or CCPM, is described as a method of planning and managing a project that emphasizes the resources like people, equipment, physical space that is required to execute the project's task. It's where Eliyahu Goldratt, the brilliant business management expert and a renowned writer who developed the critical change management in the 1997. Goldratt's ideas on the critical change project management are based on one of his earlier creations, the theory of constraint, or TOC in short. The critical change method is different from the more traditional management philosophy based on the PERT algorithm and critical path management. The methods are focused on the grid scheduling and the task order, while the critical change method is about keeping the resource level and expect more flexibility during the start time. So, how can we understand this critical change method? The critical change method has a strong focus on the project schedule. It minimizes the project chain and tries to bring down the cost of the project overrun by improving the schedule performance. It aims to bring about a more positive result by changing the project control and management system, as well as the project plan. One of the objectives is to extract a better performance from the project team and the supporting staff. This method can help minimize most of resource constraints before the start of the project and make sure the buffer for effective project control. So, how the critical chain method works? It emphasizes the critical chain and not the critical path at a project's constraint. Here is a look at how it works. It uses 50% of the probable activity time. It makes up use of buffer to account for the uncertainty and activity performance and estimate. The buffer can be used as a highly effective measurement tool for controlling the project schedule. The projects are linked to the constraining company resource using buffer, which consider factors such as activity duration variability. The method aims to modify and improve the behavior of the project team, enforce early reporting of activity, and eliminate multitasking. So next is the 5-step of theory of constraint. The aim is to keep the constraint or the bottleneck as efficient as possible, because only the efficiency of the bottleneck is a critical factor to the overall performance. There are 5 important steps to improve performance of a change. Each step will be explained with an example in the production team terms. The first step, identify constraints of the process or the system. It is important to identify the bottleneck. If the bottleneck is the machine, a maximum utilization must be achieved to ensure there's a work to do for this particular machine. Second, determine how to exploit the constraint. We must find all the way to ensure connect. This could mean reducing the number of changeover, offload work that can be done on another machine, or reduce step-up time to create additional capacity. Thirdly, we have to subordinate the system constraint. To keep the bottleneck running at a full capacity at all the time, all other decisions must be subordinate. Running other machines with a higher production rate than the bottleneck is considered as waste. Fourth, we have to elevate constraint to a new level of productivity. Concentrate all resource and effort on the bottleneck to increase the rule-out rate or the output. One way to do this is to run the bottleneck machine for extra hours every day. This increases the capacity of the machine. The difference between Step 2 and Step 4 related to the amount of investment required. In the last step, we have to start again. With increased capacity of the machine, there must be new bottleneck which needs to be addressed. The process of improvement must be repeated. So that's all for this slide. Please move to the next slide, Miss T. No, I mean the previous slide. Yes, Gongrad have asked several common practices like safety time and argue that all of they lead to the vigorous cycle that make the project sustainably late. Using the logic of his theory of constraint, Gongrad recommends that the new project could be scheduled based on the availability of scarce resources. He then suggests that the time buffer he adds in the schedule results that need feedback that feed bottleneck resource and the bottleneck resources themselves. The proper scheduling have the problem caused by poor multitasking, but does not lead to more realistic problem duration estimate. The buffer actually acts as safety time, but here is added to a batch or two rather than every activity or to the projects as a whole. Finally, Gorak argued that the two activities scheduled to be carried out in parallel and using the same scarce resource are not independent as the traditional theory would assume. If the supply of the scarce resource is not sufficient to allow both activities to be carried out subsequently, then whichever of the two is given priority immediately lengthens the other activity path and not its duration. Yes, that is the end of our presentation. Now we'll move to the MCQ part for Ms. Dong Nhi.
Hello.
Hello, teachers and mate. I'm Nhi, and I'm gonna be in charge for the very last section of today's lesson, which is MCQ, the game, or whatever you call it is. Anyway, the point of this section is to revise what we have learned in chapter 5. Because what really matters to us is whether our classmates thoroughly understand our presentation or not, which are your so please stay focused and participate in our revision time to self-check your own knowledge. Okay, may I ask for the signal of our Kahoot from V, please?
Show me. Just roughly talking about the rules.
Okay.
Send the link for them to access the code.
Because we
sorry.
because we want
go on.
involvement, so the format is designed as individual mode. Our revision contains 30 questions, and the top 3 participants make it to the podium will get bonus point from our dearest lecturer, Dr. Lee. Okay, I assume that all of you have seen the screen we is sharing, right? Because if anyone has any trouble with the screen, you should let us know as soon as possible. If not, then as usual, please go to kahoot.it, enter the game pin with either serial number on the screen of B, create your most unique nickname, and patiently wait for the other classmate to join with us. Because the time is crushing, so let's say we would wait for you to join until 12:10. Is it okay? 5 more minutes for you to join. Please don't hesitate to join. It's just a revision game.
So who is blue and who is nah? Not available. Who is that? NA. Please change your login name. Okay, lovely. Oh my God. Change your login name, please. Hello, who is that? Thank you, appreciate, but please use your student ID. Yeah. You see, today we have additional techniques. First, critical path, and when we grasp the non-critical activities, become the critical path is moving. Okay. And the last part, also talking about how to speed up. Speed up the network is one thing. Speed in video activity. That's why we talk about bottleneck. Yes. Thank you. And you know, grasping is very, very important because we identify critical paths. And after that, ranks through activity with the least cost. So we spend smart, okay, to speed up. And leveling. You have very good slide for leveling and smoothing. In terms of, how can I say, time and resource. Okay, AAA, BBB, and Love Telly, please change your login name. Hello, do me a favor. Namitu also. Okay. Okay. Very basic rule, please. Yeah. Don't worry about long. Don't worry about right or wrong. Just enjoy it. Because you know, notice we gain day by day, and this way for us to have fun, okay, with our class.
Oh,
So
I almost forgot to mention, as some of the questions require computing to figure out the right answer. So maybe you guys would love to join in with your calculator. But because we love you, so they're just simple math. Don't panic. I bet you are confident with your ability to calculate the equations in your own head. Okay, I guess that's enough. Oh no, it's nearly the limit time, guys. So be quick, please hurry. We have only 37 people who already joined in the game. Almost 30 people left. Okay, V, can you turn on the music background for the excitement? I guess some of our classmates may find it a little bit boring because they didn't hear anything. So may hope that the music background will help to cheer you up and you will gladly join with us. Remember that the top 3 make it to the podium will get the bonus point, as I have already mentioned from our dearest lecturer. So please don't hesitate to join. Hurry up, guys, we're running out of time. It's only 39 people. I wonder, where's the other? We love you, so we create a kind of simple quiz. So please love us back by joining our game. 40, still counting. Okay, we will wait until 12:15. Last word. I hope you guys will join in to play our revision time. And if you make any mistake, don't worry, because we are willing to have you after class. So feel free to contact any one of us in the group file for further information. One more minute. All right, so I guess that's enough, right? Is anyone trying to join, please? Or not? Then we'll start. First questions in critical by activities. Very easy. It's on the slide. What? What had happened? Okay, I didn't expect that. Okay, the correct answer is 2 activity times and 2 costs. It's already being written down on the slide. Exact is the slide 18, teacher versions. Okay, so please note down if you make it wrong. Okay, next questions. The formula for computing linearly over time crash cost per period is, it's very important one. Okay, only nine people got it right. Guys, please focus. It's very important for you to remember these equations. Crash cost per period equal crash cost minus for the normal cost by the normal time minus for the crash time. A hint for every one of you, especially the one who got it wrong, is that we're gonna remit these equations in our next questions. So please try to remember this equation so that you can make the next question right. Okay, next. The critical path is Planck path through the network and the Planck time in which the projects can be completed. What had happened today? Wow. Only 5 of you have make it right. Is anything wrong? Like, is our presentation a little bit too quick for you to follow? Please let us know if there's any problem. Okay. Yeah, so the critical path or path in general is the longest path in time from start to finish, and it indicates the minimum time necessary to complete the entire project. Next, please. A horizontal pie chart that shows project tasks against a calendar is called easy ones, guys. We already made one. Yeah, at least most of you got it right. It's Gantt chart. So yeah. Next, please. A project task is said to be Planck if it requires a fixed amount of time and known quantities of resources. It's system constraints, guys. Try harder next time, okay? It's already existed on slide 41, the teacher versions, if you want to revise. So a system constraint task requires a fixed amount of time and known quantity of resource. Please keep that in mind. Next questions. What aim to minimize the period by period variations in resource loading by shipping tasks within their select allowance? Yes, it's resource leveling. Resource leveling involves resolving over allocations or scheduling conflict to ensure a project can be completed with the available resource. Resources include the time, material, or tool needed to complete a project. Okay. What is the most common objective of mathematical programming? Yeah. Answer of the above probably always correct, right? Okay. Oh, let me see. There's still very leaf hanging chasing right there. Not except for the first positions. I don't know who is 219, but you do such a great job. I see you remain your first position very long time. So, okay, stay focused always. Please, next, please. Yeah, the objective of mathematical programming is to minimize the time in the shop, completion times, and limit or limit penalties for all projects. Okay, the situation questions. Mr. Kevin want to calculate the employee working hour and do the task allocations. Which approach should he use? Result loading. Congratulations to 4 people has made it right. Yeah, that I say. We never know who's gonna get the point until the last question, right? So resource loading estimate of the cost and quantity of resources. Based upon the calculations, the project managers can also predict if he needs to add any employee to the project team for the completion of the projects. Okay. Using the Planck heuristic method, the project team should complete the maximum number of tasks during a given period of time. What heuristic method is this? Yeah, it's shortest task first. Okay. So when the shortest task force is applied, the process having the smallest execution time is chosen to complete first. Therefore, within the given time, the project team would be able to complete the maximum number of activities. Okay. What's referred to the amount of time past a project due or delivery date. Yes, it's scheduled slippage. So in project management, a schedule slippage is an act of missing a deadline. In other words, it is considered as a delay in the project completion from its initial estimate date of completion. Okay, next questions. 3 important parameters used to assess the effectiveness of a scheduling system include. Wow. Okay. It's a little bit hard, right? In a short period of time. Let's see. Oh, not surprised at all with 219. But yeah, okay. So we see Luckily has made it to the top 3. Try harder. So schedule slippage is the time past the project due date or delivery day when the project is completed. Resource utilization is also a major concern because of the high cost of making resources available. In-process inventory concerns the amount of work waiting to be processed because there is a shortage of some resource. Okay, next questions. What gives a general understanding of the demand of projects or set projects will make on a firm resources? Yeah, it's resource loading. Congratulations to 12 people make it right. Okay, the top 3 remain the same. Very curious to know who are you. Okay, so resource loading describes the amount of individual resource and existing schedule required during specific time period. So the answer is resource loading. Okay, next questions. Which approach to constraint resource scheduling problems is widely used in real-world projects management? Yes, it's heuristic, guys. Okay, next. The heuristic approach to constraint resource scheduling problems is the only feasible method of attacking large, nonlinear, complex problems that tend to occur in the real world of projects management. Okay. Another question, when crashing a project, the two simple principles to follow are: be careful, a little bit confusing. Gladly, most of you have made it right. So it's a critical path and select the least expensive alternative. See what we got? Wow, the top 3, you got the best. Keep your head high. So remember, 2 simple principles. First one, focus on the critical path when trying to shorten the duration of a project. And the second one, when shortening a project duration, select the least expensive way to do it. Be patient, we're almost there. Another question. Which of the resources below cannot be inventories or renewed? Cannot. Tick-tock, tick-tock. Yes. Okay, it's time. Very easy, right? Okay, not surprised at all when we look at the top 3 people. So time itself is always a critical resource in project management, one that is unique because it can neither be inventories or renewed. Okay, next question. We halfway there, guys. Be patient. So which technique below overlap the design and build phases of a project to expedite its completion? Yes, it's fast tracking. Oh my God. Yeah. Okay, sorry for saying that they're not surprised. Now you guys surprise me. Oh, 58, you really surprised me. Okay. So lovely. If you love teacher, then show your love by getting more right answer. Okay. We really want to see you on the podium. Yeah. So, okay. Also the other student, try harder. So fast tracking only work for activities that can be overlapped. So that is also the answer for the questions. The statistical tool that depicts a project task and the relationship between those tasks is known as. Yes, it's the program evaluation review technique charts. Let's see who got it right. Okay. Yeah, it is purchase guide. It's just the full versions of the purchase. Purchase is the abbreviation form of the program evaluation review technique. So it is a chart that can also be known as a visual tool that supports project management to map out and track the tasks and timelines. Okay, next questions. What elements should be calculated to achieve the aims of the projects and also to make use of the scarce resource? Okay, the answer is schedules. Guys, is it a little bit exotic for you? Okay, it's because there are almost 30 questions. I mean, it's there a lot, right? So to cheer you up a little bit more, we decided to reward for not only 3 people, but 5 people, right? I think you guys deserve that because it's kind of very confusing and important chapter. So try to make it to top 5 and you will get the bonus point and the reward. Okay. Okay. Let's see the explanation for this question first. So schedule should be evaluated not merely in terms of meeting project's milestones, but also in terms of the timings and use of scarce resources. Next questions, we're halfway there. The 2 fundamental approaches to constraint allocation problems are yeah, I don't know if it's because I said 5 people will get the point or not, but I think it did cheer you up a little bit because I guess more people have make it right these questions. So the right answer is heuristic approaches and optimizations. Okay. So heuristic approaches employ rules of thumb that have been found to work reasonably well in similar situations. Optimization approaches seek the best solutions but are more limited in their ability to handle complex situations and lab problems. In project scheduling, planked is the amount of work waiting to be processed because there is a short of some resource. Yes, the right answer is in-process inventory. Oh, okay. Try harder. So in-process inventory is work that has begun production in a manufacturing company, but that has not yet been completed due to lack of resources. Okay. The last part of question. What is the major difference between radical change and the radical path? Oh my God. It's got me a little bit confused when 8 of you two, they are on the same? No, they're not on the same. Okay, hope that after these questions, you will figure out the difference between them. It's taking account. Okay. Oh, so the top 5, you got a top 1. The critical path is the longest chain of interdependent tasks, and the critical chain is the longest chain which take into account the interdependence of tasks and resources. So yeah, be patient about it. Little difference, but very important one. Okay, guys, please compute mathematics problem. What is the crash cost per period of 8? Congrats to those who got it right. Oh, okay. So, okay, remember when I said you guys should try to notice the crash cost per period equations? That's what I mean, because we're gonna use it in this mathematic problem. So as we already been noticed that the crash cost per period equal the crash cost minus for the normal cost over the normal time minus for the crash time. So with on the information include, we will have the crash cost per period of A would equal $100. Okay. Sorting ascending activity in a network diagram. We have activity and their immediate predecessor activity. So we sort it in ascending order. Yeah, it's ABC. Not tricky at all. We usually like hinting it away. Oh, Oh my God, did I just witness the wicked lip hanging chasing here? Oh my God. I saw like for the rest 20 more than 20 questions. We always got to see 219 on the first ranking, but now 065 has saying like, hold my beer, I'm gonna take your place. Okay, guys, this has been very excited, so please keep your head high always and focus on the very last questions. Okay, there's still few more. So according to the table, activity A doesn't have predecessor activity, so it would be the first one. And B is the predecessor activity of A, and C is the predecessor activity of B. So the correct order would be A, B, and C. Okay. Next one. A few more questions left for you to reach in top 5. Please compute the project's completion time. All right. You guys are good at calculating the simple equation in your head, right? As I have told you, it's very easy. Okay. Around to 17 people got it right. Okay. So the project completion time would equal 35 weeks. So, new technology enable us to carry out activity C in parallel with A and B. So what is the project completion time now? Yeah, it's 30 weeks. Oh, see, the love power has back to the game. So because we make the activity C equal to B to A and B, so the project completion time now is only equal to the durations of activity A and B, which is 30 weeks. Okay, very last one, guys. If the managers consider B and C can be shortened to 20 weeks, so what is the best project completion time? Yeah, it's 30 weeks. Because 35 is higher than 30 weeks, so the best project completion time would be chosen is 30 weeks. Okay, so very nervous. Who's gonna make it to the podium? Oh, but don't worry, we still keep our promise for the question. Okay, so it's 062. Yeah, you definitely draw our attention. You trying to stay low for the reverse questions, but then you pop out and ruin it. Okay. All right, so we have top 5 winners. So whoever you are, please don't forget to show your true identity to us so that we can note you down to Dr. Lee for bonus point. Okay? So last word, thank you, teacher, for offering us this opportunity to present and our classmate for your contribution. We really appreciate that. Bye.
Yeah, thank you very much. Hello, class. I hope you all doing well. Especially we under your leadership, your team work also very, very, very well. Okay. I think we have passed and get many experience when selling, when preparing. Okay. But I know you lead the team in very good way. You arrange the tasks into many example. So with that, hello student, do you have any questions? Hello, do you have any questions? Okay, I know the top. Okay, I record here the top 5 people, not only 3 people. Đặng Lam Phương, Khánh Linh. Let's see. Phan Minh Thư, Trần Nguyễn Ninh, Nguyễn Huy Khánh Minh, Bùi Nguyễn Quang Minh. Hello, can you hear me? Khánh Linh.
Yes, yes, sure.
Yes. Nguyễn Đặng Phương Lam. You did a great job. Okay. So let me review some more things. First, you see in the screen right now. Do you see it clearly? Hello. Do you see it clearly? Okay. Hello, student. I want to ask one question. You know, this is the result of graphing. So, what are or what is critical path in your screen right now? In your screen right now, what? Identify critical path now. Hello? Ngô Văn Hiếu, are you there? Hello, Hiếu. Thế Vinh, in the screen right now, what are critical paths? So, yes, for sure. Yep. Okay. Here. So you can chat. You can see here. Hello class. All are critical paths. A 110. B, C, D, E. Okay. Sum up also 110 days. B, F, E. Okay. 17, 14, so 110. You see, previous week, last week, I told you sometimes might be old, but at least one critical path in the network, own way. Okay, this is critical path. Okay, yeah, and we recognize that. So in order to do so, let me review. Hello class. Okay. We identify this. Okay. Actually, for engineering work, how much you estimate? Okay. And this is assumption is linear. Okay. Assumption in some aspect is linear. And I remember when I teach the course scheduling and sequencing, one chapter also project scheduling and insert. We have such code how to run a project. So with the minimum slot, we select first. Okay. So it's very easy for you to step by step to carry out step. Okay. Compute. Okay. And also for coding, you can use many kind of software or language to code. Okay, so remember one by one and step. Okay, select the activity. Okay, a critical path with the least cost. Okay, and in the graspable amount. Okay, some activity cannot grasp furthermore. Okay, so there are steps for you to carry out such kind of process. Okay, so you can see what is the requirement. Many problems in reality. In this case, this is J1. The project to be complete within 110 days. This is one question. But how much? Can we do that? Yes or no? If yes, how much? Okay, right? Another problem. They say they have some amount of money to crash the project. Speed up. Okay, shorten the completion time of project duration. Okay, so they say they have 10,000. So which activity to craft first, and what is the optimum way to grab the project? You know? Yes. Okay. So with that, many problems to solve. That's why we learn project management, and today's special is crafting. Next, we talk about leveling. Okay, so we run the activity with the least slot. Least slot. Slot, it means cost per day. First, second, third, etc. Okay, and we select always in the critical path, and you review after crafting. We review what are or what is critical paths, and to apply it again and again. Always compare with the expectation requirement. Expectation might be the number of days maximum in the duration. Okay, expectations or requirement. Requirement might be within the budget. Okay, they have, for example, 5,000. Okay, additional cost for you to craft. So with that, we see, we identify. Oh, craft activity. Somehow. Okay. The next smallest slot. Okay, so with that we also can sum up. Oh, so far to reach 120 days. Okay, this is called step by step. Okay, and we review critical path, and we compare alternative on this course A and B. Okay, A and B. Okay, one by one. This is the most simple. Okay, for you to have a feeling. Okay, good feeling. Now we have to review critical path, list cost, and alternative. We combine which one? Okay, because some case, some activity in different parts, and their part also critical part. Okay. So to summarize like this, I have one question. Do you have a question? Huh? Hello. Okay. Any question? I have questions. I have questions. Could you please name a sample of classing activity in your student time? Lê Đình, Thắm, Hạnh. Hello, can you hear me? Hello. Huh? Oh. You see that? Hello, student. Okay. You see in the chat box? Thắm?
Yes, yes. I saw your message.
Yes.
Yes.
I want to add it here also. Classing activity. Now you see in the screen clearly. Huh? Hello. You see it clearly or not?
A little bit bigger, please.
Okay, let me see. Bigger. Let's see. Oh, okay. Is that okay now? Let's see. Name a sample of classing activity in your student life. Phương, you have an answer. Cut down time doing homework because there are too many homework and project. How can you cut down time? Doing so? How?
Well, I have to sometimes I I will do the homework with my friends,
Yeah.
or
Good.
I will try to look for examples on the internet so I can know the way to finish it faster.
Yeah. Okay. In doing so, Phương, in doing so, we have sometimes we have to spend more. Okay. Very good. Okay. Good. What else? The example. Lê Đình Khánh. You can chat it here. Class. Learn and practice. See around you. It's meaningful. Okay, Queen. When I don't study hard in the process, at the end, what is that? When I don't study hard in processes, and at the end, I need to pay more money to take it more. Okay, one. Wonderful. Okay, that's correct. What else? That is simple. That is simple. Thank you, Tâm.
Yes, are you calling me teacher?
Yes.
Yes.
What is your example? Cẩm Nhung. Cẩm Nhung, are you there? Hello, Cẩm Nhung. Yes. Hello. Yes, we Phương, wonderful. We register full credit at some semester to finish university quicker. Okay, good. What else? Furthermore, Duy Phương, very good. Cẩm Nhung, are you there, Nhung? Forget to ask you, huh? Hạnh, you want to say something?
Dạ thầy ơi, bạn Nhung đang đi vệ sinh, thầy đợi bạn.
Okay.
Dạ.
So here's a sample. We have registered extra class. Yes. Hạnh, wonderful. Yes. Yes. Lê Đình Khanh. Wonderful. Yes. Okay, Duy Phương. Yeah. You see answer in the chat box from Duy Phương and especially Khanh. Okay. Daddy. Wonderful. Oh. What else? Actually, there are some more, but you see that we want to review next. Would you please give an example of scare? Okay. That's wonderful answer. What else? Okay. Do you have anything else? Let me show you a sample. Here, resource. You see all locations, your job. Okay, because you schedule, you plan, because resource limited. Sometimes, okay, we want, let me give an example. Sometimes we want to carry out activity A and B, that is. But the first, we don't have space for two machines. Okay, we don't have space. Yeah, you can see in the project normally like that. Remember, in the construction site, maybe in the mountain, when you move, okay, one machine from the port to the mountain, you can see some construction in the remote area. Very hard to bring such machine. So they accept. Okay, accept. Only one machine. Okay, okay. Not two machines to do parallel, but only one. Yes, I saw many cases. People in the remote area, I saw how can they do only one machine day and night. Okay, okay. Why not several machines to increase the capacity? But after that, you know, think, okay, it is very hard to bring machine over there. The first, the second, in the very narrow space, very hard for them to run two machines backward, forward, and cross to each other. Okay, so this is very meaningful when you lost the capacity, and because of that, we have to review. That's why we consider all resource loading and smooth leveling. Okay. With that, I think physical contract. For example, like this, if you want have some more machine, can you work? Okay. Yeah, that is why we can do. Let's see. Software to save time drawing, technical drawing. Okay. Yes, you can speed up. Yes. Okay. That's why we need to equip. Okay. To invest in some kind to speed up the capacity. That's true. Quyên. Now, hello class. In this, you can see if you have more machine, how can you work? Physical constraint, safety, very important. The most important. Okay, you can see the noise, the humidity, moisture, temperature, lightning, space. Okay, where is the escape route? Okay, so that is what else? Heuristic, yes, for sure. That's why we do many projects. We know more. Okay. Any question? This one is very familiar with you. Okay. And this is also okay. Mathematical model, linear programming. I can show you. Especially who study OR1, multi-objective decision making, and scheduling, sequencing. Okay. Any question? Otherwise, I would like to thank you all. Hang on, huh? Not too much over time, huh? Please save and see you next week. Okay. Okay. Hello.
Yes, thank you, teacher.
Yeah, thank you. Do you have any question, especially at the group who have? Hello, group 7, Lê Thúy Quỳnh, Xuân Hân, Hồng Nhi, Bảo Trâm, Thu An, Tố Trinh, and Thùy Linh. You have a project. Any question for your project? The case study. Hello. Group 7. Okay. If no, I would like to say goodbye now and see you next week. Okay. Okay. Bye bye for now.